Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video we'll continue from the last video, continue from where we stopped. So yeah, which is to derive or to get the expressions for different parameters. Okay, so actually what we are trying to arrive at is our voltage gain and current gain, okay, which is a output voltage over input voltage, output current over input current. Then at the end we just set the the output current over input current, we take it as this, output current over input current gain. And then for the voltage current, we take it as voltage gain, we take it as this, okay, output voltage over input voltage, take it as this. So let's work step by step and get all the parameters we need. Okay, so let's go. So the first thing to do, we already have our output impedance, so let's get our input impedance. Now I can solve with this color. So for our input impedance, let me even put that here, output impedance, I mean, for output impedance. So for output impedance, it is or it equals what? Back to the diagram. Now looking at this diagram, this is what we are working with now. Recall that we said to work with this diagram, this network in the AC domain, we need a model of it so that we can apply the KVL, KCL, and current divider rule, voltage divider rule, and things like that. Those circuit analysis technique, for us to apply them, we need this AC model, which we have done, or which we did in the last video. So please check out that video so you just follow up. So now this AC analysis, because what we are doing now is AC analysis, because we've removed the DC source. Look at it, we remove the DC source to get to this point and then drew the model. So what we are doing now is AC analysis. Okay, so now the output impedance now equals, we are working with the model now, equals, what do we have here? The sum of all the impedance or resistance in the outputs. This is the output, right? This is the output, and this is for input. Okay, so the sum of all resistance in the output, and of course we can see that this is parallel to this. So what we do now, we can apply that a simple arithmetic of that parallel system of adding resistors in parallel, which is this. I think I like to use small letters for everything here. Okay, well, you can use your capital letter, no big deal, no big deal. Okay, so let's continue with that. Now, of course, this in parallel simply means we have them multiplied here, RC RO all over RC plus RO. But the thing is this, RO is very large, okay, where RO is very large, in fact 10 times larger than RC. Okay, so again, how do I know that this is 10 times larger? Well, based on the principle or how the transistor is. Okay, based on how the transistor network is, or the properties of a transistor, based on the properties. So based on that, RO is very large, 10 times larger than RC. So if something is like really that large and you add another thing to it, the effect will not be there. That means it's like a drop of water in the ocean. That drop of water is like nothing. Okay, so that means what we have here will just be RC RO all over RO. So what we have here will just be RO. Okay, so, and of course this equals this guy will cancel out. Will cancel out, and what we have is just this equals RC. Okay, so this for our output impedance. That's what we have for it. We've gotten that. Next is our output voltage. Output voltage. So for output voltage. Thank you. So for output voltage, VO equals, now recall I said some voltage of course is I, voltage of course is IR, right? So coming to this, the network now, output voltage IR. So what's the I in this network now? What's the I here? Beta IB. We already solved for this now. Of course, the current in this network, in the output side, the current in this network here is the IC, and of course IC equals beta IB, which is this. So it's beta IB. Okay, then what about resistance? Of course, our resistance is this in parallel to this. Okay, so we'll have that equals, or implies that this is beta IB. Okay, and then the R is what? RC in parallel with RO. Of course, we've solved this to get, look at it now, we've solved this to get this RC. So everything here will just be RC actually. Okay, will just be actually. So this will just be beta IB RC. Recall the recorder, the menu. Recall that we said something about the direction of current. Saying that this is output current, this is the output. So we are supposed to have this going into the network or into the system, and this going out of the system. But since our arrow is drawn into the system, that means we will have a what? A negative sign. I think I said this in the last video of this one. So you have a negative sign. So we'll come back here, and yours truly, we have the negative sign. Okay, good. So that's that for that. We can hold this here. We may come back to this, but just hold it here. Okay. So next, we've gotten input impedance already. So the next thing to do is our gain.